problem. So that's why ಒಂದು ನಿಮಿಷ ನಾನು I will try. Otherwise, I will without video. I have to discuss with you. ಹಲೋ ಈಗೇನಾದರೂ ಕಾಣ್ತಾ ಇದೆಯಾ?
ಹೌದು ಸರ್.
ಒರಿಜಿನ್ ಅಂಡ್ ಎವಲ್ಯೂಷನ್ ಆಫ್ ಅರ್ತ್ ಅಂತ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
ಹಾ ಸರ್.
Okay. Only thing, my photo is not visible, isn't it?
Yes, sir.
Forget it. However, all of you have seen me, and there is no issue. Okay, shall we start?
Yes
Hello.
sir.
Yes, sir.
Huh?
Yes, sir. Yes, sir.
Okay, please, for the time being, all of you unmute your mobile. So mute your mobile, and I will allow you in the end for unmuting, and we will discuss at that time. Is it okay? Hello.
Okay, sir.
Okay sir.
Okay. Please mute all your mobile because all the disturbances will be there, the noise and other things. I know all of you are at home, and there will be disturbances. So good morning to all of you.
Good
Uh,
morning sir.
Good morning,
Good morning
sir.
sir.
After a long while, we are meeting again via the technology that is made available. Uh, and this semester portion already Dr. Bhatt and Sureka madam must have told you. That is the very interesting chapters like histology, evolution, paleontology, and so on and so forth. So I will start with the evolution. It's a pretty interesting chapter because all of you must be wondering why there is such a diversity in life, starting from microscopic organisms to these gigantic creatures like elephants or whales. In between, you have an array of organisms of different shape, size, color, texture, isn't it? Both in plants as well as in animals. How all of them over a period of time developed and how they are, why they are presented so. So this must be the curiosity that is lying in all the minds, not only for the students of biology or science, even for a layman also, uh, maybe thinking or it may be tickling his mind to understand this process. But many times what we say that one word answer, why it is so, how it has happened, we will say that it's because of evolution. Now the question comes, what exactly meant by an evolution? Undoubtedly, what we see today is the result of evolution over a long period of time. So, but this what actually meant by an evolution, how it has been achieved, and how it has helped us in realizing the present day scenario, what we expect today. So this literal meaning of what we call evolution is nothing but unrolling or unfolding. Now you may ask how this term unrolling or unfolding is helpful in understanding the process how the living beings have attained this much amount of diversity over a period of time. See, here this unfolding or unrolling is the literal meaning of evolution, but here in our present context, we have to consider it as, or we have to add a suffix to it, that is unfolding or unrolling the life over a period of time. So that's why this particular evolution is both, if you want to study that, we should understand both spatial and temporal aspect because here two things are involved. One is the space and another one is the time. Space, what I feel is refers to this earth or the place where all these living beings are found and they are changing over a period of time. That's the time frame. So that's why the process of evolution has two parameters to justify, one being the space and another being the time. So over a period of time, this has achieved. And we also call it as organic evolution because nowadays term evolution is used in many contexts, in many walks of life. But here, being the students of biology in general and geology in particular, we say that it is the organic evolution because whatever the evolution or development, changes, adaptations, rolling, unfolding of life has taken place in the organisms, that is, the organic molecules in particular. Basically, it is in the organic molecules and which over a course of time change into an organism and presented in this form, shape, size, etc., etc. So on and so forth. Now, when I say evolution is nothing but the study of unfolding or unrolling the life over a period of time, you may ask me how this life came into existence first. Because the evolution, most of the time, we start from the beginning of life and from there, the present day life what we see. But the very basic question or most pertinent question would be how the life originated on this, how the life originated and where. That's also equally important question. Where the life originated and how the life originated. For this, as of our information goes today, we can see life only on the earth. Though we say that there are many stars, many planets, but what we see as far as present day knowledge is concerned, we don't know. I don't deny that there is no life in other parts of the universe and all those things. It may be another debate. But for the to limit myself, I can say that as far as our knowledge goes, the life is found only on this earth. So when I say that at present what we know is the life present only on the earth, then you may ask what made the life to develop and evolve only on the earth? Why not on other planets? If you take our solar system, there are how many planets are there in solar system? Hello? Can you hear me? Hello?
Yes,
Hello?
sir.
How many planets?
Yes, sir.
How many planets are there on the in the solar system?
Yes.
Huh?
Planet.
How many planets?
Eight planets.
Eight planets.
Eight
Is it?
planets.
Eight planets.
Eight.
So then you can see the
Sir.
life only on the Earth means on the as of now we say that remaining seven planets are almost sterile planets. No life on this Earth. Now the coming back to my earlier question, why the life is found only on this Earth? Why not on other planets? Isn't it? So for this, probably the most significant thing what we do is first to study about the Earth, how the Earth has evolved, and how the conditions on this Earth promoted the evolution as well as the development as well as the origin of this life. So first let me start with the origin of the earth and evolution of the earth, and then we will start with origin of life and evolution of life. Is it okay? Let this be our strategy. First, before understanding the origin and evolution of the earth, I would like to introduce few terminologies for you. Unless we make ourselves familiar with these terminologies, we will not be able to understand the origin and evolution of the earth. So that's in the glossary. All of you might have heard one term what is known as the galaxy. What is galaxy? Galaxies are large system of stars, dust and gas which are bound or held together by the gravitational force. So these galaxies are large system of stars. Probably when on a dark night, if you come out and stand in an open place or on the terrace of your house and look at the sky, there you can see large number of stars. Dust and gas bound particles are not seen, but at least what you can see the large systems of stars. And you may wonder why they are positioned there, because every time the star table is available, with the help of star table you can locate the star in the sky. How it is possible? Because the stars, dust and gases in this universe, they are held together by the gravitational force. And this large system of these stars, dust and gases, they are appearing in different shapes. Some cluster of stars, dust and gases may be elliptical, some may be spiral, and many of them are irregular in shape. Our sun, which is a single star, is a part of one galaxy, which is spiral in nature. Our sun is a part of a spiral galaxy, and that galaxy is known as Milky Way.
ಸರ್
Yes, tell me.
ಸರ್ ಏನು ಕಾಣಿಸ್ತಿಲ್ಲ ಸ್ಲೈಡ್.
Slide ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ?
ಇಲ್ಲ
ಈಗ
ಸರ್.
ಇಲ್ಲ ಸರ್.
ಎಷ್ಟೊತ್ತು ಕಾಣಿಸ್ತಾ ಇತ್ತು?
ಇಲ್ಲ
ಫುಲ್ ಬ್ಲ್ಯಾಕ್
ಕಾಣಿಸ್ತಾ
ಆಗಿ
ಇದೆ.
ಕಾಣಿಸ್ತಾ ಉಂಟು
ಆ?
ಸರ್. ಫುಲ್ ಬ್ಲ್ಯಾಕ್ ಕಾಣಿಸ್ತಿದೆ.
ಈಗ
ಇಲ್ಲ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ.
ಒಂದು ನಿಮಿಷ, ನಾನು ಇಲ್ಲಿ ಚೇಂಜ್ ಮಾಡಿದ ಕೂಡಲೇ ಬರೋದಿಲ್ಲ ಅದು. ಇಟ್ ಟೇಕ್ಸ್.
ಸರ್ ನನಗೆ ಕಾಣಿಸ್ತಾ ಉಂಟು ಸರ್, ಬೇರೆಯವ್ರಿಗೆ ಕಾಣಿಸ್ತಿಲ್ಲ. ಸರ್ ನನಗೂ ಕಾಣಿಸ್ತಾ ಉಂಟು.
ಹಾಗಾದ್ರೆ ನಿಮ್ದೇ ಯಾಕಂದ್ರೆ ಐ ಕೆನಾಟ್ ಇಲ್ಲಿ ಸಿಲೆಕ್ಟಿವ್ ಆಗಿ ನಾನು ನಿಮಗೆ ಇಬ್ಬರಿಗೆ ಕಾಣಿಸೋದು, 3 ಜನರಿಗೆ ಕಾಣಿಸೋದು ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲಲ್ಲ. ನೋಡಿ ಈಗ ನಾನು ಚೇಂಜ್ ಮಾಡಿದೆ,
ಸರ್
ಚೇಂಜ್ ಅದು
ಗ್ಯಾಲಕ್ಸಿ ಸರ್ ಕಾಣ್ತಾ ಇದೆ. ಗ್ಯಾಲಕ್ಸಿ ಸರ್
ಕಾಣಿಸ್ತದಲ್ಲ.
ಕಾಣಿಸ್ತಾ ಇಲ್ಲ
ಕಾಣ್ತಾ ಇಲ್ಲ ಸರ್.
ಅಲ್ಲ, ಕೆಲವೊಬ್ರಿಗೆ ಕಾಣಿಸ್ತದೆ ಕೆಲವೊಬ್ರಿಗೆ ಕಾಣಿಸೋದಿಲ್ಲ ಅಂತ ನನಗೆ ಇದು ಆಶ್ಚರ್ಯ ಆಗ್ತಾ ಇದೆ. ಒಂದ್ ನಿಮಿಷ ಮತ್ತು ನೋಡೋಣ ನಿಮಗೆ. ಬಟ್ ವಾಟ್ ಐ ನೀವು ನಿಮ್ಮ ವಿಡಿಯೋವನ್ನು ಆಫ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ? ಇಲ್ಲ ಇಲ್ಲಿ ನಂದೆಲ್ಲ ಸರಿ ಇದೆ ಅಮ್ಮ, ನಾನು ಇಲ್ಲಿ ಎಲ್ಲ ಇದು ಮಾಡ್ಕೊಂಡಿದ್ದೇನೆ. ಸ್ನೇಹ ನೀ ಕಾಣ್ತದ?
ಹೌದು ಸರ್.
ಈಗ
ಕಾಣಿಸ್ತಾ ಉಂಟು ಸರ್.
ಓಕೆ. ಇಲ್ಲ, ಯಾರಿಗೆ ಕಾಣಿಸಿಲ್ಲ ಅವರು ವರಿ ಮಾಡ್ಕೋಬೇಡಿ. ಬೈ ಈವ್ನಿಂಗು ನಾನು ಇವತ್ತು ಏನು ಹೇಳಿದಾನಲ್ಲ ವಿತ್ ದಿಸ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ನಾನು ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಹಾಕಿ ನಿಮಗೆ ಅದನ್ನ ಲಿಂಕ್ ಅನ್ನ ಕಳಿಸ್ತೇನೆ. ತಿಳಿತಲ್ಲ? ಈಗ ಜಸ್ಟ್ ಕೇಳಿ ನೀವು, ಆಮೇಲೆ ಓಕೆ. ಈಗ ಕಾಣಿಸಿದವರೆಲ್ಲ ನೋಡಿ, ಯಾಕೆಂತಂದ್ರೆ
ಓಕೆ ಸರ್.
ಈಗ ನಾನು ಅದರನ್ನ ಓಕೆ. ಸೊ our sun is also a part of the galaxy. ಪ್ಲೀಸ್ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಇದನ್ನ, ಯಾಕೆಂದ್ರೆ ಭಾಳ ಏನೇನೋ ಹಕ್ಕಿ ಕೂಗಿದ್ದು, ನಾಯಿ ಕೂಗಿದ್ದು ಎಲ್ಲ ಸೌಂಡ್ ಕೇಳ್ತಾ ಇದೆ. ಪ್ಲೀಸ್. Sun is also a part of the galaxy, and that galaxy is known as Milky Way. And this Milky Way, it is about 2/3 of the way out of the center. So this, for example, the Milky Way contains not single stars. As I have told you, Sun is one such star, and we have 500,000 million stars. Then you imagine the number of stars that you are seeing. That only in one galaxy in which we see, our solar system is also a part, that is known as Milky Way, and it is about 500,000 million stars are there. And if you weigh them, the total mass is equivalent to 1.9 million suns. If you put 1.9 million suns together and weigh it, that is the weight of our Milky Way galaxy. So then see, this is the one photograph which shows there are entire galaxies billions of light years away. So where I have put one galaxy, see, this is one galaxy. Can you see the, especially I am focusing on where I am moving this cursor, that is the Milky Way galaxy. And these are all other galaxies, are there, so many galaxies together it is formed. And this is another photograph of a galaxy where uh, Milky Way is also a part of it. Now, coming to the galaxy in which our solar system is also there, it is known as Milky Way. It is the galaxy where all of us live. It is almost a spiral shaped galaxy, and the Milky Way contains, as I have told you, 500 million stars, that are 200 billion stars, including our sun. And if you measure the width and breadth of that one, it is about 1 lakh light year across and 10,000 light years thick. I hope all of you know what is light year. The distance the light can travel in 1 year, we call it as light year. How much distance a light can travel in 1 year? That is 1 light year, and the width of our Milky Way galaxy is 1 lakh light years, and the depth is about 10,000 light years. So if you are at a place and in a dark night, you can sometimes see the entire Milky Way as a thick band of stars in the sky. We are in this Milky Way also. We are in the suburb of the Milky Way, not near the center, not near the edge also. See, this is the Milky Way, how it's a spiral galaxy. And our sun is here, where I have marked with a red rectangle and an arrow pointed at that. This is the center or nucleus, and so our Earth, our solar system is here. Our sun is here, and surrounding that it is uh, different planets are revolving, which all of you know. So this is it's one photograph of the Milky Way, and on a dark night when there is no cloud, if you look at it, sometimes with your naked eye you can see all these spirals, but you have to observe carefully, and for that you need certain education also. Only then, after the term galaxy, is it clear what I have told? Now I would like to introduce one more term, the nebula. Nebula is nothing but a cluster of interstellar gases and dust, that we call it as nebula. The dust and the interstellar dust and hydrogen gas which is around the sun, we call it as solar nebula. So because this nebula is the raw material for the formation of any of such solar system that we see today. Basically, our solar system is the result of this nebula, and our solar system has utilized this nebula so as to form a functioning system. Our solar system began forming the concentration of interstellar dust and hydrogen gases. And this interstellar dust and hydrogen gas together we call it as molecular cloud. What happens is these molecular clouds, they concentrate under the own gravity, and as a result a protosun, young sun, sun, not son, huh? Young sun, protosun, was formed with a very hot dense center, and whatever the cloud that is remaining, which is swirling like a disk surrounding this protosun, we call it as nebula. So that's why nebula is nothing but a swirling disk which is made out of interstellar dust and hydrogen gas. That is called as solar nebula. See, Here in the center you can see the sun. Surrounding that, can you make out here? There's a swirling dust and the gases. That together, which is surrounding the protosun, is known as solar nebula. So in general, nebula means the condensed interstellar dust particles as well as the gases, mainly the hydrogen and helium gases. We were talking about the origin of the earth. When the earth started or originated, age of the universe is approximately 14.5 billion years. Almost the universe is 10 billion year older than the earth. Almost it took 10 billion years in the universe for the formation of the earth. So age of the universe is about 14.5 billion years and age of the earth is about 4.5 billion years. In order to understand how the earth originated, we should know some of the chemistry and physics of this universe, because there was no biology at that time, no living beings. It was only chemistry and physics. Early universe has only protons and helium nuclei, and rest of the were the elementary particles and the radiation. Early universe only protons and some helium nuclei were there. Probably about 14.5 billion years back, first stars were formed, what we call primary stars, from hydrogen and helium. And we many call them as protostars also. So rest of the elements formed in this protostar by the process what is known as nucleosynthesis. Rest of the elements were formed in the protostar by the process what is known as nucleosynthesis. Initially what we had in the universe were hydrogen and helium only. Then what has happened when these primary stars or protostars are formed? These stars are also dynamic. Some of the stars of some critical size exploded, and this exploded condition of the stars we call it as supernova. All of you might have heard the term supernova. Supernova is nothing but some of the stars, primary stars of critical size, they exploded. As a result of this explosion, hydrogen, helium, which were initially present, and newly formed elements which were formed by the nucleosynthesis in the core of these stars scattered as intergalactical dust. Hydrogen, helium, and newly synthesized elements, they started scattering in the universe, and that is what we call intergalactical dust. Some of the stars exploded and formed the supernova, and they contributed to the formation of intergalactic intergalactical dusts. But what happened to the other stars? Some other stars become black holes and brown dwarfs. What are these black hole and brown dwarfs? I will come to that later, little bit later. So I have told you, when because of the supernova, the explosion of these primary stars, intergalactical dust were scattered, and this intergalactical dust led to the formation of secondary stars. Even our sun is a secondary star, not a primary star. So these intergalactical dust particles contributed to the formation of secondary stars, and these secondary stars now they contain orbiting debris formed from the elements of the first generation star. When the second from the first generation stars, as a result of supernova, when the intergalactical dust scattered, and they contributed to the formation of the secondary stars, including our sun. But there will be a lot of other materials which are the result of this supernova, and these debris started orbiting around this secondary stars, the newly formed star, including our sun, and they inherited an angular momentum, and this angular momentum made this debris to orbit around the main condensation center, and as a result they gave rise to orbiting planets. Now coming back to the black hole, what is this black holes? You must have read in newspaper or in many of the scientific articles, because black hole is a very important thing. These are the dead stars, I can say that, where an area of space and time with gravitational field is so intense that its escape velocity is equivalent to or exceed the speed of light. They are such a concentrated mass of the dead star and this one, dead stars, that with a very high gravitational field, so intense, even radiations will not escape from their gravitational force. So intense that its escape velocity is equal to or even more than the speed of the light. That we call it as black hole. And this black hole can be of any size. A gigantic star after death may collapse into a black hole of a very small size, but the gravitational force of this black hole is tremendous. Like that, brown dwarfs. These brown dwarfs are again stellar like objects which are seen in the universe, but they are small so that they will not light up. They are very faint. Even with the elliptical telescope, you will not be able to see them. Especially some of the dust particles, interstellar dust particles, which are of smaller size. Because of their small size, they are unable to light up. So that's why we will not be able to see them with the elliptical microscopes. That is what we call the brown dwarf. So here this is this thing. What happens is amount of energy is very less. So that's why as soon as the energy is produced, they are immediately used up. As a result, they will be leaving them in dark. For example, the planets such as Jupiter is also a brown dwarf because they are smaller size, but they form differently and can not burn hydrogen. So their energy synthesis is very low. Like another one, the red dwarfs. But these red dwarfs are massive enough to support the thermonuclear reactions. So that's why these red dwarfs can be seen with optical telescopes, because they release thermonuclear reaction, undertake thermonuclear reaction and release energy so that they can emit light, but not the brown dwarfs, because the energy, since this is so low, that whatever the energy that has been released is immediately consumed up, and they will not be able to emit any light. Okay, after galaxy, nebula, black hole, brown dwarfs, I would like to introduce one more terminology, that is planetismals. What do you mean by this planetism? Going back to what I have said about the solar nebula. In solar nebula, we have dust particles, ice particles, gas. All of them are embedded and they are churned. When they swirl, naturally they collide with each other. They collide with each other. The dust particles, ice particles in the gas. When they collide, they may merge with them. And this particular process of collision as well as merging of this dust and ice particles in the gaseous filled environment, we call it as accretion. Basically, all of them are microscopic particles. But when large number of such microscopic particles merge, they form larger bodies, considerably larger from microscopic dust because of collision and merging. They fuse together. Sometimes dust particles fuse together, and as a result, the size of the dust particle increases. When the size increases, mass also increases. When the mass increases, there will be more gravitational force. As a result, they go on attracting more and more smaller dust particles, and these smaller dust particles come and merge with this larger dust particle and making them to grow in more and more size, increasing mass also, and thereby increasing the gravitational force. So when these microscopic particles, because of accretion, develops into larger bodies of few kilometers across, of considerable size for us. Few kilometers across means it is a considerable size for us, but if you compare to the vast expanse of the universe, this is nothing. This small bodies of few kilometers across, we call them as planetismals. In other words, we can say that they are the basics of the present day planets what we see. In these planetismals also, there are different types. The planetismals which are very close to the sun, the inner hotter part of the solar nebula, they are composed of mostly silicates and metals because of the high temperature. But in the outer periphery, which are much cooler portion of the nebula, even if you today analyze water and ice, water in the form of ice, if I am to be more precise, water in the form of ice is the dominant component. So these larger size bodies which are formed as a result of accretion, we call it as planetismals. See here a photograph where you can see number of such planetismals. The planetismals, very close to the center of the solar system, they are mainly gaseous and silicate and metals, other metals you can expect. When you move away like this to the periphery, where you can see many of the planetismals are made out of ice also. They are scattered. Not only scattered, they are orbiting around the Earth. See here, you can see the stages. The planetismals are smaller bodies which are formed from dust and gas. Can you see the photograph?
Yes, sir.
Can you see?
Yes, sir.
Okay. In the first photograph, you can see the planetismals are formed of the smaller one. And here, what happens in the planetismals also you can see of different sizes. Some planetismals will be larger, some will be smaller. As I have already told you, when the size is more, mass is also more, gravitational force is also more, they will attract other planetismals and they merge together and thus forming what is known as the protoplanets, larger one. See, in the second photograph, you can see less number of planetismals, but little bit larger one, and they are what we call protoplanets. And these protoplanets fuse together and form the planets, where you can see. In the third photograph, where you can see there are only 8, where these protoplanets fuse together, so they are so as to form a planets. See, this is what you call the accretion disk, which is passing through the center, and all these dust and cloud, they are in a swirling mass. So this is how actually the planetimals are formed as a result of accretion. Now, like Milky Way, I would like to introduce one more nebula, what is known as Orion Nebula. Orion Nebula is called as star nursery. What is nursery? Nursery is the one where young plants or animals are raised or taken care of, isn't it? So here, Orion Nebula is important for us because it is considered as the unit where young stars are nurtured. It's a part of large gas and dust cloud in the constellation known as Orion. And here the closest stellar nurseries to us is about 1500 light years. And the entire this Orion nebula cloud spans over several thousand, several hundred light years. Why I have taken this one is, here you can see many of these newly formed young stars. In this region you can see they blink in the interior of the dust cloud. They are all young stars. So remember, in the universe stars die, they become black holes. As a result, and not only that, even new stars are also formed because our sun himself is a new star, it's a secondary star. So this nebula interstellar cloud of gas dust collapse under the own gravity. When they collapse, interstellar cloud of gas and dust collapse under their own gravity, new stars are formed. So the Now, I was talking about swirling of gases and formation of a disk, what is known as accretion disk. See, this is the gaseous particle. I hope all of you can see where my cursor is moving. It is the center. Center here there will be some solid particles, and solid and larger in size, they have gravitational force. So this gas is attracted towards it, and when they attract, they move, and it is in the form of swirling dust. See, like this, all they are held together, and ultimately, most of the, for example, even if we take our solar system or the Milky Way in general, they have taken the elliptical shape. Most of them either round or elliptical, but there are certain galaxies where they are irregular in shape also. Here is a photograph where you can see this is what was seen even prior to the formation of the present day sun. It is nothing but interstellar dust and gases. Because of this swirling movement, they have taken the shape of a disk. This disk we call it as accretion disk. In this accretion disk, first what is formed is the planetismals. From planetismals, in the next stage, they develop into protoplanets. And in the very recent years, something 4.5 billion years back, these protoplanets evolved into what is known as the planets and revolving around the sun, which is centrally located in an elliptical shape. So now let's try to understand or understand this process of formation of entire solar system in general and Earth in particular. It took almost 14.5 billion years. Actually, our solar system is very young. It's only 4.5 billion years back. Gas and dust, fine dust, they are blown away after approximately 10 million years from the present day solar system. And probably the Jupiter must have been formed because of the blown out gas and fine dust. So here the Earth in the center and planets revolving around the sun in a definite orbit. It is not only true for the sun, even for all the stars. See here, this is the proto-sun, and afterwards, these were all initially the planetismals. Very near to the proto-sun were rock and metal. Beyond that, icy compounds which are embedded with the rock and metal. Because very close to the sun, temperature will be very high. The water is not there. There is only hydrogen and helium gas. But beyond the snow line, where the heating effect of the sun is less. So as a result, there is a very cold climate, icy compounds in which rocks and metals are embedded. You can see them. Now the question is, what is the composition of the planet? Let's discuss only about two planets. One is Earth and Jupiter. In both Earth and Jupiter, hydrogen gas is the major gas. Helium is also in the gaseous form. Carbon on the Earth is in a gaseous form, but in Jupiter it is in the form of soot. That's a solid. ಹೊಗೆ ಅಂತ ಏನು ಹೇಳ್ತೀವಲ್ಲ ಕನ್ನಡದಲ್ಲಿ ಆ ಟೈಪ್ನಲ್ಲಿ. Nitrogen on the Earth is in gaseous form, but whereas on the Jupiter it is ice because Jupiter is beyond the snow line. Oxygen, of course, on the Earth it is in the form of water vapor or it may be in the form of ice, but in Jupiter we don't know. Silicon is rock-like in both Earth as well as in the Jupiter. Now, coming to the formation of early Earth, though till now we have discussed about the general principles which are lying behind the formation of any planet. But coming to the formation of the early Earth, initially the Earth was in like this, where you can see in the photograph A. See what were there? Sodium, potassium, oxygen, aluminum, silicate, all these metals. But it was a homogeneous mass of these elements and gases in, and as a result the density of the planet was also very low density protoplanets were there. When this started revolving like this along the accretion axis, thus forming an accretion disk, the concentration of these things happened like this. In this, you can see some of them are heavier, some of them are lighter. The heavier elements, they sink into the center, like iron and nickel. They are heavier. They started forming the core, and slightly lighter elements like magnesium, calcium, aluminum, potassium, silicates surrounding this iron and nickel core. And surrounding that, there will be more lighter gases like helium, xenon, like that, hydrogen. So this all of you know, when you put it for centrifugation, same thing happens. The heavier particles sink in the bottom, lighter particles will be above that, still like lighter particles will be still above that. Same thing has happened. Now, the earth core is mainly made up of some of the heavier elements like iron and nickel, surrounded by having a buffer zone made out of calcium, sulfur, aluminium, calcium. Yes? Any problem? Can you hear me? And surrounding that there will be more lighter gases like helium, hydrogen, etc. So now this is a cross section of one orbit, solar orbit, through which spinning disc-shaped nebular clouds illustrate the forming the planets by condensation of planetary. Here I have told you the Mercury is more diffused here, less diffuse. Earth is still less diffuse, and because it is See, very close to the sun, there will be 1000 degrees Celsius. Next, it will be 500 degrees Celsius. And if you move away, the temperature falls. Near Jupiter, it is almost zero. So that's why you can see an ice state made up of hydrogen, carbon, and nitrogen. The dusts are mainly made up of iron, calcium, and aluminium. At See, this is at different distance from the sun. This is the sun, where the temperature is about 5000 degrees Celsius. More than, huh? Actually, among the planets, we have two types of planets: Jovian planets and terrestrial planets. Jovian planets are also known as giant planets. So these Jovian planets, they have lots of solid in the disk, and core is made out of ice, rock, and metal. They grow large and very quickly. Because of their size, they are big enough to trap hydrogen and helium gas from the disk. Whereas the other planets, the terrestrial one, very little solid material in the disk, and the disk is also made up of only rock and metal, not ice. It grows very slowly, and the size is too small so that they fail to trap any gas from the disk. So this is the chronological order how the earth has been formed. The oldest sediments that dates back to 3.8 to 3 point, in between 3.8 to 3.9 billion years. Oldest sediments of the earth were traced near Greenland. These sediments are meteorites, bombardments. Oldest rock we found it around 4 in between 4 and 4.1 billion years. Oldest strata or zone bed is of about 4.2 billion years. About 4.5 billion years, the entire earth was formed. Even the formation of moon, which is a satellite to earth, has also been formed. See, even if you go back to 1 million years, this is habitable zone. 10 million years back, habitable zone was not at all there. And if you take the Jupiter, of course, it is not there at all. 3 billion years ago, there was nothing. This is another photograph how dust, rock, and planetismals, embryos of embryo planets and planets are formed. First starts like this, moves like this, accretion disk is formed, protoplanets, planetismals, protoplanets, planets, and the present day condition is achieved by the accretion of solid particles. So there are many good hypotheses about the origin of the solar system. About this, probably I will discuss that in the next class. Now, all of you switch on your unmute your microphone so that if you have any doubt, if you have not followed anything, feel free to discuss. Hello,
Hello, sir.
hello, ಕೇಳ್ತಾ ಇದೆಯಾ? ಏನಾದರೂ ಡೌಟ್ ಇದೆಯಾ ಅಥವಾ ಹೇಳಿದ ಅರ್ಥ ಆಯ್ತಾ?